Welcome back to PV Online. Today we're going to talk about work. And doing work is going to be really important to us in that that's how we accomplish most things. Our definition of work is going to be you have to apply a force that's parallel to some distance that you're going to travel. So if you're standing there holding a box, by the physics definition, as long as the box is just stationary, you are not doing work. In order for work to be done, you have to apply a force over some distance. And all we're interested in is the force that's parallel to the distance. Now, in terms of units, the unit for work is going to equal a Newton times a meter, and we call that a joule. And we just abbreviate it with a capital J. Now, you're probably more familiar with the English unit of work, which is a calorie. Food calories is how much work your body's doing. Now up here we have this nifty equation where it says work equals force times distance times the cosine of theta. And that's because the only component of that force that we want when we're applying it at an angle is the component that is parallel to the displacement. Now, if my angle is 0, then if you take the cosine of 0, that gets you 1. That's where we get the work equals force times distance. So let's take a look at 3 scenarios. And in diagram A, we've got the simplest form of work. And in this case, we have a 100 Newton force. So we have our applied force is trying to move this 15 kilogram object a distance of 5 meters at constant speed. So I have my force that's to the right. I have my distance that's also going to be to the right. So in that case, it's simply going to be work equals force times distance. And that's going to give me 100. And the distance was 5 meters. I'm going to have a total amount of work of 500 joules. Now in the second case, instead of applying that force perfectly horizontally, we're now doing it at an angle. Since my displacement is still 5 meters to the right, I only want the component of the force that's parallel with the displacement. So in this case, I want the component F cosine of my angle, which is 30. So when I do my calculation, it's simply going to be F times D times the cosine of my angle. So we have our force, which is still 100 newtons. The distance is still 5, but I only want that component of the force that's parallel with the displacement. That's going to give me a work of 433 joules. Now last but not least, in this case we have an upward force is applied to lift a 15 kilogram object to a height of 5 meters at a constant speed. So since we're moving at a constant speed, I know that the force up has to equal the force acting down. You weren't given an applied force, but since we know these forces are balanced, I know that my applied force has to equal mg. So now when I calculate my work is going to be the force that I have to apply, which is mg, times the distance, which happens to be the height that we're traveling. I'm going to take this mass, which is 15, times my 9.8, times my distance, which is 5. That's going to give me a work of 735 joules. Finally, let's take a look at this example. We have a crate that's being pulled to the right with a force of 100 newtons, and it's moving a distance of 12 meters. But this time we have a frictional force of 20 newtons acting on it. And our question is to find the work done by each force. Now, as soon as you see that, make sure that you are sure that you have all of the forces acting on the crate. And my force diagram is not complete. So in addition to needing the applied force and the frictional force, I need to remember to include mg and the normal. Now I have a completed force diagram. Let's go ahead and start calculating this. So let's first find the work done by the 100 Newton force. Now since I'm finding a total of 4 different works, I'm going to write the subscript so that I know I can keep track of which ones. Remember, it's just force times distance. The applied force is in the same direction as the displacement, so all I have to take or do is take 100 times 2, and that's going to give me 200 joules. The next one I need to do is the work done by the frictional force. Now, this is simply going to be the frictional force times the distance. They're parallel with one another. However, friction's going in the opposite direction, so I'm going to make that a negative 20 times 2, and that's going to give me negative 40 joules. Next, let's take the work done by the normal, and it's going to be the normal force times the distance, but these two are perpendicular to each other. If I entered cosine of 90, that would give me 0. So the normal force is doing no work on the crate. Finally, let's do it for gravity. Again, this is going to be mg times the distance. Again, mg is perpendicular to the displacement. That means there will be no work being done by gravity. Finally, we need to find the net work. And that's going to be, after all is said and done, what do I have left? And so all we have to do is sum up the works that were done, which is the 200 joules done by the applied force minus the 40 joules done by the frictional force. That means I'm going to have a positive 160 joules of work done on the crate. All right, we'll see you next time.